Now let's see another example on how we can calculate the allele and genotype frequencies. A farmer has 2,000 cows. A total of 1,500 of the cows are brown coated and the rest are white coated. Allele B for the brown coat is dominant, while another allele B for the white coat is recessive. Assume that the population of the cows is at genetic equilibrium and they breed randomly. From the questions, we have the information about the total number of cows is 2,000 and 1,500 of the cows is dominant. So the number of cows that shows recessive phenotype is 500. Now let's try to answer this question. Calculate the frequency for the dominant and recessive alleles of the population. We will start our calculation with the frequency of recessive allele, Q. P plus Q equal to 1. So P equal to 1 minus Q. First step, we find out the recessive cow. The recessive cow is 2,000 minus 1,500. That is 500 cows. So Q square equal to 500 divided by 2,000. Q square equal to 0.25. The square root of 0.25 will be 0.5. So the frequency of recessive allele Q is 0.5. Then for the frequency of dominant allele P, since P plus Q equal to 1, then P equal to 1 minus Q. So P 1 minus 0.5. So P is 0.5. For question B, calculate the genotype frequencies in the F1 generation if the cows are left to breed randomly. So for this question, we need to calculate the genotype frequencies in the F1 generation. So the genotype frequencies, it consists of P square for homozygous dominant, 2PQ for heterozygous, and Q square for homozygous recessive. For this question, we will list down the equation P square plus 2PQ plus Q square equal to 1. Based on the previous question, P is 0.5 and Q is 0.5. So, to calculate the frequency of homozygous dominant, P square equal to 0.5 square. So, it's equal to 0.25. Next, to calculate the frequency of heterozygous, 2PQ, 2 times 0.5 times 0.5 equal to 0.5. The frequency of homozygous recessive is Q square. Q square equal to 0.5 square. So frequency of homozygous recessive is 0.25. Question C. If the farmer adds another 1,000 homozygous dominant brown cows into the population, calculate the new dominant allele frequency. This question is a little bit tricky because the farmer add 1,000 homozygous cow. So the migration occur in the population and the population is not in genetic equilibrium. So we will use gene pool method to calculate the new allele frequencies. In the original population, there will be 500 homozygous dominant cows, and in the new population, after added with 1,000 homozygous dominant, the new population will have 1,500 homozygous dominant cow. And in original population, the number of heterozygous cow is 1,000. In the new population, the total number of B alleles dominant is 2 times 1,500 plus 1,000. That's equal to 4,000 alleles. The total number of alleles in the new population is 2 times 3,000 equal to 6,000 alleles. The frequency of dominant allele B equal to total number of dominant alleles B divided by total total number of all alleles. 4,000 divided by 6,000, or 2 times 1,500 plus 1,000 divided by 2 times 3,000 equal to 0.67 or 0.667. Question D. State 3 conditions for the Hardy-Weinberg equilibrium to be achieved. For this question, we can state any 3 conditions for Hardy-Weinberg equilibrium. For example, no migration, no mutation, no natural selection, large population size, random mating, or random fertilization. Here is another example of calculation using Hardy-Weinberg equation. So question number 1, albinism in human is controlled by recessive allele. In a population, the frequency of albinism is 1 for every 40,000 individuals. The question asks about what is the frequency of allele A, recessive. So we are looking for the value for Q. From the question, the total number of homozygous recessive is 1 and the total population is 40,000. So to calculate the frequency of allele Q or recessive allele, Q square equal to 1 over 40,000. Q square equal to 0.000025. So Q is the square root of 0.000025 is 0.005. Since the answer is in percentage, so 0.005 times 100 will give us 0.5%. So the answer is B, 0.5%. For question number 2, the ability to test PTC in a population is due to the dominant allele, while the inability to test PTC is controlled by recessive allele. From the question, in the population, 70% able to test PTC. That means 30% is not able to test the PTC. The question asks about the frequency of allele T recessive. So we are looking for the value for Q. Q square equal to 30 divided by 100. Q square is 0.3. So Q is the square root of 0.3 is 0.548. It can be rounded into 0.55. So the answer for this question is D, 0.55. For question number 3, the genotype frequency of mutant, which is recessive homozygous, is 0.16. What is the frequency of mutant allele? So we are looking for the value for Q. From the question, Q square is 0.16. So Q is the square root of 0.16 is 0.4. So the answer for this question is C, 0.40. Yeah. Question number 4. The frequency of allele B dominant in a population at genetic equilibrium is 0.7. What is the frequency of BB heterozygous genotype? The frequency of heterozygous genotype is 2pq. From the question, the frequency of dominant allele B is 0.7. So P is 0.7. Since P plus Q equal to 1, then Q equal to 1 minus P. 1 minus 0.7, so Q is 0.3. The frequency of genotype BB heterozygous is 2pq. 2 times 0.7 times 0.3. That is 0.42. So the answer for this question is B, 0.42. Yeah. For question number 5, The cystic fibrosis is due to the recessive homozygous. 1 in every 2,000 individuals suffer with this ailment. The question asks about what is the frequency of allele related to cystic fibrosis in that population. So Q square equal to 1 over 2000, that is 0.005. Q is the square root of 0.005. Q is 0.022. So the answer for this question is B, 0.022. So that's all for now. See you again in the next video. Thank you.